All right. So first thing is that I forgot to make the Google Sheet accessible to you. I just put it in there. So when you open it up, okay, it's just going to say view only when it finally gets open. Okay, so what you have to do in order to make your graph and spreadsheet and everything is just go to File, okay, and click Make a Copy. All right, copy of that, and you're good. Then you'll have one to load it. Okay, in the end, you don't even need to submit this part. Okay, you're going to copy the chart over, you're going to copy the graph over into your lab report, and that's all you're going to need anyway. Okay, so don't worry about it. As long as you've done that, it'll say copy of U3, and you'll be able to put in your data and make your graph and everything there. Okay, and then you also have obviously the Google Doc, okay, that you guys will be working in and submitting to me. Okay, so you'll have your analysis table here that we'll talk about in a little bit, okay, that you'll have to fill in, and then the procedure obviously to do here. So here's what we're looking at. Okay, so the problem we're investigating is that the change in velocity of a vehicle measured over time tells us acceleration. How can graphing help us to calculate acceleration? All right, there's only one kind of graph we've gone over that will help us to calculate acceleration. What kind of graph is that? Ooh. Okay, well, you'll figure it out. Because, uh, velocity, time, right? The velocity versus time graph will tell us, okay, if we do it right, okay, what the acceleration of the object is. All right, so for our design here, okay, I'm going to give you a hand with that because we're not actually running an experiment, so it's not going to seem quite as clear. So the experiment that was run in order to get this data that we're going to use, okay, was that every single car on the list was brought to the same place, same track, on the same day, with the same driver. Okay, and they were all accelerated as hard as possible, okay, to essentially 45 meters per second. Okay, they were timed to those various speeds that are listed there. Okay, which makes time our what variable? It's our manipulated variable. Okay, it's going to be going on the x-axis, which is where manipulated variables always go. Because either some of them don't go that fast, or the sensor didn't work when they actually ran that particular run. Okay, I would assume that's probably what happened here for the Dodge Charger. Okay, I assume that the sensor probably didn't work there. But when we're talking about the Toyota Corolla and the Volkswagen Beetle at 45 meters per second, maybe they just didn't get there, or they just took too long and they stopped timing or something. Yeah. Okay. All right. So everyone kind of follow on that. Okay. So we've got time as our manipulated variable. What's the other thing that's on our graph? Ah, there we go. Velocity, right? Okay. This lab is entirely about velocity versus time graphs. All right. So we're going to have velocity as our responding, time as our manipulated. Okay. And then I gave you a description of what the experiment looked like, and I said a whole bunch of things were the same. Those might be called controlled variables. So there you go. Okay. So what that'll help with your design part here. Now for the hypothesis, okay, I don't want to use what's written here, okay. Here's what we're going to do for the hypothesis, okay. In the if part, I want you to tell me what acceleration is. Essentially, you're going to give me a definition. If acceleration is this, okay. Okay. The and part is going to describe what we're going to do here. And that is we're going to make velocity versus time graphs of some cars, not all of them. Okay. Make velocity versus time graphs of some of these cars' acceleration data. Okay. Then tell me how you'll get acceleration from the velocity versus time graph. Okay, we talked about how we would do that. Okay, this is going to be a single straight line graph. It's not going to be a graph that has multiple parts. All right, so we're looking for a particular property of that line, okay, for that part of the hypothesis. Okay, for this lab, you are going to have 5 separate graphs. Okay, do not try to put all of these things on one graph. It's not going to work. Okay, just it ends up looking really, really messy. So, okay, you're going to make a different graph for each car. Okay, the way that you do that, okay, is that when you are looking at your Google Sheet here, right, you can just make sheet 1, okay, just click on here, just rename it and make its name whatever car you're going to do. Put in the data, okay, make the graph, copy it over to your lab report. Then, when you're done that, okay, add a new sheet. Name that whatever the second car you are choosing to do is, put the data on there, make a graph for that car. Okay, you're going to do that, okay, for 5 cars. You don't have to do all of them, you have to do 5. So you can pick whichever 5 cars from that list it is that you want to graph. Okay, so you're going to select 5 cars, you're going to create a graph of velocity over time for each one. Okay, plot the points on your graph, ensure then the scales will be fine because Google Sheets will figure that out. Okay, you're not going to use this formula here because Google Sheets is going to spit that out for you if you tell it to use the equation as a label. So you'll have y equals, then you'll have the slope, and then you have x plus whatever the y-intercept is. Okay. So once you have that, okay, then you're going to fill in your analysis chart. So once you've built the graph for each car, you will use that graph in order to fill in, okay, the chart here in the analysis. All right, so you'll list the name of the car, you'll put in the slope with units, okay, you'll put in what B is with units, okay, you'll rank the cars from fastest to slowest, fastest being 1, slowest being 5, okay, and then you'll have to calculate the displacement while reaching 45 meters per second. Okay, so you got to calculate how far they go in order to reach 45 meters per second. I'll give you a couple of tips on that when we get there. Okay, but for right now, that's the other thing you have to do. Okay, so you're going to fill in this chart. Okay, and then you got 2 more questions after that. Okay, so from your data slopes, which cars accelerated the fastest? So that's filling in this column. Okay, question number 3. Okay, using your best fit line, calculate the displacement of each car in reaching 45 meters per second. Even though some of them don't go to 45, we can still calculate that, okay? Because our line will go that far, even if our points don't go that far. Everybody follow? Okay, so we'll be extrapolating a little bit. So remember that in order to do that, you're going to have to determine how long it takes for each car to reach 45 meters per second. Okay, so if you're going to calculate how far they go, you need to know how long it takes in order to reach 45 meters per second so that you can use your line and the shapes under it in order to get your displacement. Okay, everybody follow there. All right, so you'll use y equals mx plus b to get the time, then you'll find the displacement after that. Okay, I want to see your work for that question. So if you're doing that on the computer, that's fine. If you're doing it on a separate sheet of paper, same as last time, take a picture of your work and insert it so that I can see it that way. Okay. All right, then you have a conclusion. So were you able to calculate the acceleration in the way that you stated in the hypothesis, explain why, and that's it. There's no sources of error here because we didn't run this experiment. Okay, so we don't know what the sources of error really were because we weren't there on the day it was run. We can guess, but we don't guess. Okay, so there's no evaluation part on this lab, which means this lab's only out of 27 and not out of 30. Okay, I'll still make it worth all the same as all the others, but okay, it's just not worth. It's not out of 30. Okay, so is everyone following what we're doing here? Okay, so same as the usual lab, except you got to make 5 graphs, but that won't take you very long. So I'm going to go over one graph here just to review for everybody how the graph is built so that there's no problems with that. Okay, all right. Okay, so to get this started here, the first thing I'm going to do is change the name of this sheet to Ferrari, because that's the car I'm going to graph, because it's the first one in the thing. Okay, this is going to be time in seconds. This is going to be velocity in meters per second. All right, and then I'm just going to fill in the numbers here. So the velocities are going to be 0, 13, 18, 22, 31, 35, and 45. All right, so and that's the same for every car, right? That's the same for every car. The times are what's different for every car. So the time for the first one is 0, okay, and then for 13 meters per second, it's 1.6 seconds, and then 2.1 seconds, and then 2.6 seconds, and then 3.7 seconds, 4.5, 5.7. Oh, what did I miss here? I missed a row. I missed 27. Hold on here. Sorry, I missed a row there, guys. So this should be 3.7. This should be 4.5. This should be 5.7, and this should be 7.9. Okay, so now I've got all my data input for the Ferrari. So I highlight it all. I go up to Insert, Chart. Okay, it always picks the wrong one. So instead of column chart, which is what it says here, I click on that. I go down to Scatter. Okay, I don't want it to look like this, so I want to click on this box here, use column A as labels. Okay. So then I get a better looking graph. Okay, it's important that we check this box right here. Okay, use column A as labels. All right, so now that I've got that, now I'm going to go to my Customize menu, okay, and I'm going to put in the stuff that I need here. So I'm going to say Ferrari graph, okay, for the chart title, and then I'm going to put in for the horizontal axis that it's time in seconds, okay, and for the vertical axis, it is velocity in meters per second. Okay, and then I'm going to click on series. Okay, series is where I make sure that everything kind of looks right and where I get my trend line and all of that kind of stuff. So point size isn't all that important for this. You can make them bigger or smaller if you want to. The most important thing is right here, okay, where it says trend line. We want to tick that box. So we get our trend line on there, and then we want to use our equation. Okay, so we got to go down here to label where it says none. Click that and tell it to use the equation instead. Okay, and it gives me the equation up top here. Okay, you can change where that goes in the legend menu, right? You can leave it up top. I always like to have it on the right-hand side. I don't know why it goes over there now, but okay. All right, so now I've got my equation. So it says the equation here that the slope is 5.46 times x plus 4.71. Notice there are no units in there. Okay, you'll have to figure out what units belong on each of those numbers. Okay, now that I have that done, okay, all I have to do is copy that graph over. I don't need to copy the chart. I already have the chart, right? The chart's already in my lab report. I don't need to copy it over a second time, right? So all I'm going to do is close up the chart editor now. Okay, click on this, copy it over into my lab reports. Okay, so it says insert graphs below. All right, perfect. I'll put them right there. Link it, and There it is. There's my Ferrari graph. Then I'll put in the next one underneath that. So this is going to be a bit long because they're all going to be in there. Don't shrink them down. I want to be able to read them. Okay? If you shrink them down too small, okay, then I can't see what I'm looking at. It's not like we're printing this on paper, so we're not saving any trees by making them small. Okay. All right. Now, like I said, to do the next one, okay, then you click on the plus button here to add another sheet. That gives you a blank sheet. Do the next car on that sheet, and so on and so on. Okay. Everybody follow what we're doing? Okay. Get to it.